Hi, this is Margo. This is Sunday evening, November the 28th, 2021. I hope everyone is safe and doing as well as possible. I'd like to welcome everyone to the show tonight. This will be my weekly update on methane and sea ice for the Arctic and the Antarctic and other climate-related items. And we'll be putting this up on YouTube as my weekly update. I can't believe another week has flown by. It's just, it's like a lifetime in a day practically, but things are moving really fast now. So we're going to start with the methane part of the show. This is from the NOAA data. This is the 477/469 millibar reading. This is the Met-OT-1, aka Met-OT-B satellite. It's the only satellite that we get readings on now. This is for the morning on the 27th, which was yesterday. The mean or average was 1926 parts per billion. The high reading was 2505. In the afternoon, the mean was 1924 and the high reading was 2493. Now you can see those numbers have gone down. So that averages out to be 1925 parts per billion. That's a decrease since last week of 2.5 parts per billion. So that's 2 weeks in a row we've seen a decrease. So here the blue line is going down. And we're in the season now that methane should be going down, and it should be going pretty much steadily down now rather than stair-stepping. So we'll see how long it goes down. We'll see where we bottom out this winter. It's really not looking good. So we're still 18.5 parts per billion higher than we were a year ago. We're 55.5 parts per billion higher than where I started measuring here on March the 1st of 2019. And I'll take you through what happened this week. Here we were on the show last Sunday. This is the data for Saturday. It was at 1927.5, and that was a decrease for the week of 3 parts per billion. Then on Sunday it went up 1 part per billion. Monday it went up 0.5. Tuesday it went down 0.5. Wednesday it went down 2 parts per billion. Thursday it went down 2.5. Friday it popped up 2.0, and then Saturday it dropped down 1.0. So we did quite a bit of stair-stepping this week, but the overall was 2.5 lower than where we started out last Saturday. And generally, methane goes down in the winter time, and then it starts up in the early spring. But in the last few years, it started up in January and February, and so it's not much of not many months of it going down before it starts on its way back up. So we'll see. It stair-stepped so much. It peaked out on October the 2nd on the satellite, this Met-OT-1 satellite. It peaked out at 1936 parts per billion on October the 2nd. and it's just been kind of up and down, and now it looks like we're headed into the decrease, the market decrease. And next week is December, so if we only have a month, if it starts going back up in January and we only have a month of decrease, we won't have much time for it to go down. So we're in runaway on all of this stuff. So now we'll look at the CAMS data. This is out of the EU Copernicus Atmosphere Monitoring Services website. I have Saturday the 27th pulled up, Arctic view and surface level. Here's our color ledger at the bottom. The data is for Saturday, and the forecast period is Sunday through Wednesday. So we've got a lot going on up here. See all these releases coming out. This is the Laptev Sea that moved out from the coastline, but this is coming up through the sea ice and it's still billowing around Komsomolets and another area that a little bit independent, a little bit away, or 2 or 3 different areas is coming up here in the North Kara Sea. Now the sea ice this is all coming up through sea ice. Now at Komsomolets, there is quite a bit of open water right around the coastline, but this has been billowing for almost 2 years nonstop, and I'm thinking this is part of the Russia military territory, since no one is investigating this high release for so long. There's probably certain areas that the researchers are allowed to go to, and this is probably not one of them. Otherwise, someone would have been out there with a flask to capture some readings, I would think. See, it's popping up here in this East Siberia Sea and the Chukchi Sea there, and it's like a kaleidoscope. It flings out and then goes swirling around. Let's see, here it comes across to Alaska and then around, and then on land we can see that the Norwegian area is coming back to life. Northern Russia is coming back to life with really high releases, and I can only think it's from permafrost thawing is what's causing this. But it just goes to show that just because it gets colder doesn't slow down the methane. We also have this high reading near Koktovik in Alaska. And greens, and then the chartreuse color and oranges as background colors. So very high readings here. Even though methane's going down overall, globally, we've got very high readings up here and in different parts of the globe, mainly in the northern hemisphere. Now we'll look at the North Pole view. Here's France, here's Spain and Portugal. We're seeing some high readings pop up all the way across east of there. Here's the Persian Gulf. Here's India. See, it's still filling up pretty much. And it's spilling over the coastline still. Here's the Bengal Bay and the Arabian Sea, very high, spilling over. And China, you know, it goes through these waves that move out about every 4 or 5 days. See, at the end, see it's bursting out there. Korea's filled up. This is, here's Russia. This is where the Russia border is, and China. Then over here in North America, see these waves just moving out. It looks awful. From Texas up, and then just depending on the day, you'll see the big blobs come in. In the forecast period especially, it's looking worse. And California is just totally filled up. See, all the way down, it's spilling out over the coastlines too. Now we're going to hop down to the Antarctic. Now, I've been watching this for the past few months down here and found that there is definitely methane coming up around the coastlines. We can see it. And now the primary color down here is the dark blue. This is as a result of the overall methane levels going down. This light blue is 1820 parts per billion. This darker blue is 1800 parts per billion, like navy blue. So generally that's the main background color now, and so we can't really make out the Antarctic coastline from the border, from the black line, because it just blends in. But you can see where the light blue pops up. See, it's coming up around the coast, and this is southern. This is next to the Ross Sea. This is the Ross ice shelf here, but there's a big area here of release. And then this whole western peninsula, especially on this eastern side, see it's popping up. Also on the western side, down here in the Weddell Sea, look at it all the way across this Weddell Sea. This is the Brunt ice shelf here, and then we can see it popping up on the north side. Right here is the Amory ice shelf, and and then here on this east side, I don't know the name of this one. It's quite dramatic to see it popping up through the dark blue, and most of it is like in that 1820 20 range, I would say. Some of it might be in the 1840 range. And the sun is up down here. The ozone hole is still pretty big. It's covering about half the continent. So that's not helping matters any. So we saw the higher reading pop up here just then. So that's not looking good. Now we'll go to the global view. And same thing, it's hard to make out Australia with the black lines, but we can see the methane coming up around the coastlines. So that's kind of outlining the continent. New Zealand, kind of the same thing. There's more methane on the North Island than on the South Island at New Zealand. See, it's higher, I should say, not more, it's higher reading popping up there. We're starting to see some purple. See the purple, like hazy color there, here in the Indian Ocean, here in the Pacific. Let's see where else. Here next to Australia, and that's this color right here. That's 1780 parts per billion, so a little bit lower. But this whole northern hemisphere is still primarily green, is the main background color, the dark green at least, and that dark green is 1920 parts per billion. It's at least that and higher for most of the northern hemisphere. Okay, there's that. Now we'll look at 500 HPA. That looks awful, doesn't it? Even though it went down, look at it. The highest readings are these dark blobby areas here in Russia, Siberia. Also here, this is this is Taimyr Peninsula. Right here is the Laptev Sea, and here's Novaya Zemlya. Here is Severnaya Zemlya. So it's highest right here. We also have a high reading here in the Barents Sea, just north of Norway, Finland, and this little part of Russia, Murmansk. And then we've got reds all the way across. Now, I had a question pop up in the comments. I think it was Sultan Bev who said, why is it that we're seeing such high readings over the Arctic at 500 HPA, and then it looks washed out? It looks washed out, what, at surface level or total column? And I'm not sure how to answer that. You know, I'm not a climate scientist, so I don't know how all of this works exactly. I do know that with different layers of the atmosphere, you have different pressures, and you know, methane is quite light, and it likes to gather at certain altitudes, and it also it likes to gather over colder areas. And so Now it's cooling down over the Arctic, and in the summertime it didn't look like this. It was more spread out, more dispersed in the summertime, and now in the wintertime it's looking worse. And I've noticed this is kind of the pattern, so I think it has to do with just, it tends to gather more densely at a certain altitude. It doesn't mean that that's the highest reading through the whole atmosphere. And when we look at total column, this is where they add up all the methane through all the different layers of the atmosphere to get the total reading. And so here now the highest readings are here in China, and then we got some more reds spreading down through southern Asia and India. We've got reds over the Persian Gulf and just popping up different places. So that's the only way I know to answer that. And I'm sure there's, if you want to dig enough and do some research there, you could find the answer. So anyone who'd like to do that research and share it with us in the comments, I'll be glad to share it in my show next week. But that's just what I've noticed, that it's different patterns during different times of the year. So that's all I know about that. I wanted to show, while I'm here, carbon dioxide. Now I don't show this very often, and so when we do see it, it's a real shocker to see the change here. This is total column, global, and it looks awful, and it's definitely going up, and we can see there's no cream color anymore, even over the Antarctic. And in the southern hemisphere we used to have more cream, and even down into the kind of the blue-green, but no more. It's all going up into the browns. And just as an example of these greenhouse gases gathering more at different layers, if we look at, now this is interesting, I was just looking at this today. If we look at surface level, this is what it looks like at surface level. So that's real different. That's where it's being produced. Now this is from the fires in Africa and South America. And then if you go through the different layers, it's different. Let's look at 500 HPA. That's pretty heavy. That's about the same as total column, but we can see it's more dense with the swirling around, and it's more dense, see, over the top part of the northern hemisphere. Now if we look at, you're going to flip out when you see this, 50 HPA, that's right at the very edge of the atmosphere, right where it goes into outer space, and look how dense it is. It's denser, big band, wide band around the center of the Earth, and it's a lot thinner at the poles. So it just depends on the certain gas and I think the time of year, and also you know, where it likes to gather in the atmosphere. Look at that. That's awful. And if we refresh, we'll get the right color ledger. Remember, anytime you change these levels, it changes the color ledger. So here, this this highest reading, it is between 410 up to 600 parts per million. That's that. That's what's there. It's awful. And then total column is, that's what it looks, that's where it's added up through all the different layers where it's heaviest. And if we refresh, see, this goes up to 1,000. This highest reading is 420 to 1,000 parts per million. So where you see it the densest, it's anywhere in that range. That looks awful. Okay, now we'll go through the rest of my pictures here. This is sulfur dioxide today. Total column. Here's from Palma. Now it's been kind of slowing down with sulfur dioxide, but look at just this solid, the cream and the gold. These are higher readings, you know, that just spread out over this whole northern area. And sulfur dioxide is a real heavy gas, and once it gets to 500 HPa, it tends to hang around there for a while. This is popping up from Popocatépetl. Here's the ozone hole over the Antarctic today. See, this is the area that's still in the danger zone inside this black line below 220 Dobson units. It's getting smaller slowly, but it's still quite thin. And the aqua and the green and the chartreuse, that's still quite thin. The solid yellow is 300 Dobson units, and that's considered to be kind of average or normal. A good ozone is at least 300 Dobson units or more. So it's not looking good. Here's the Arctic view of the ozone. We've got a thinning here next to Iceland and Greenland, see. And we're getting more reds come in around the Arctic region. Here's the global view. It's, you know, it just stays kind of thin all the way around the mid-latitudes of the planet. And we've got a thinning and over the western part of the U.S. again. And see this break here from the Antarctic coming up to Africa. Here's pictures of La Palma today. This is there was a new vent that formed. It's still blowing up ever since September the 19th. And here's the lava flowing down today. Here's where it's spewing up. That's out of the new vent today. Or fountaining. That's not a spew, that's a fountain. That's all of those. Let's go over La Palma next while we're here. Okay, this is from Zoom Earth earlier today, and we can see the ash and smoke, this cloud. It's streaming to the southwest now. I've got the heat layer turned on, and if we zoom in, this is where the lava is flowing. It had kind of stopped going into the ocean for a couple of days, but now with the new vents and new flow, we've got a whole lot going into the ocean again. So it's kind of taking over new areas. Here are the earthquakes. This is La Palma. This is from EMSC. When I loaded this up, there were 109 earthquakes in the last 24 hours. If I refresh it, let's see what it is now. 130. So it's going up. So the earthquakes are on the increase. I'm seeing mainly 2s, a few 3s in here. So let's look at volcano discovery. They put up 3 updates today. So let's see. We'll go through these. Normally they'll do a main update with everything that's going on, and then if there's more that happens, they'll do a little short one. Okay, here's the first one. New vents open at northeastern side of the cone, generating lava fountains and new lava flows. Look at that. Here's another picture. Let's see. A view of the lava fountains and flows at dawn. That looks surreal, doesn't it? Several new vents opened this morning at the northern and northeastern base of the main cone, producing lava fountains and emitting new lava flows that travel around the northern side of the cone. This comes as a result of a new surge of magma that announced itself as underway by the recently observed inflation during yesterday and the previous day. Inflation means the ground inflated with the magma. Instead of erupting through the existing vents at the cone, like on Thursday, the magma chose to create new vents nearby. Likely the older conduits of the cone have become too high excuse me, and too difficult to reach compared to creating new fissures at the base of the cone. There it is. Here. That's at the base. That's the new vent. And there's the cone. Okay, so that was a short one, just to tell about the new vents. So sorry about my voice, I can't help it. Here we go. This is the big update for today. Largest eruption in 500 years. There's the picture. The lava flows from the new vents have quickly crossed the Taconda Road and are enlarging the northern margin of the flow field, covering new, so far untouched land in that part. Updated data on the extent of lava flows and maps can be expected tomorrow. The ongoing eruption is already counting as the largest on La Palma Island in over 500 years. It has likely overtaken the 1585 eruption at Taihuya as the largest by volume eruption on the island in recorded history. The latter erupted approximately 300 million cubic meters, or 0.3 cubic kilometers of lava, while the exact volume of the current and still ongoing eruption is estimated to be at about this value already. Along with the new vents allowing magma to quickly rise through a new and compared to the older vents likely easier path, volcanic tremor has jumped up significantly this morning. At the same time, the inflation from the past days has been neutralized by an almost equal deflation signal. This suggests that the extra amount of magma stored recently has been erupted during the ongoing surge of activity that began this morning. How long it will last will be shown in the near future. The opening of the vents was not accompanied by significantly changed seismic activity, which indicates that the magma needed little energy to break through the ground at nearby locations as before. Earthquakes have increased marginally in numbers but not in energy during the past 24 hours. The NGI recorded 91 events of magnitudes up to 3.5. The activity of the old and new vents produces dense ash plumes rising to 1,600 meters above sea level and drifting southwest over the Atlantic Ocean and sparing the airport on the east coast. That's what we saw on Zoom Earth. As to the other lava flows, activity continues to feed them as well, according to the latest official summary of the situation. The flows labeled number 7, 4 to 5, and 1 through 9, as well as 10, which has emerged with number 11 further south but stopped its advance. Various active fronts are fed by the tube system, almost notably in the area near Laguna Hill. The total area covered by lava flows, including the lava deltas, stands at 1,151 hectares. There's that. And we got one more to look at. And I post these on my Subscribestar page as public posts. I'm posting the main ones. And, I don't post all of these advisories, but I post these updates with the pictures. Okay. New lava flows quickly reach several kilometers length. The image shows the eruption from the new vents this evening as seen by our group on the La Palma volcano special tour currently on location. The new lava flow from the fissure on the northern side of the cone have already reached a length of a few kilometers, and their fronts have reached the area of La Laguna as well as Dos Pinos. Watch the latest aerial drone videos of the El Paso government. So there are a couple of videos. I'm not going to play them. I don't want to maybe get a strike here. But you can go to Volcano Discovery and La Palma News and get all the latest. So there's that. I'm going to close that out. going to move on to the sea ice. We're going to start with the slideshow from Climate Reanalyzer. I download these images every day. So here we are today with sea ice and snow cover for the Arctic. Here's where it's coming back along the Greenland coastline on the east side. Here's where it's come back in the Baffin Bay. It's really thin up here at the north end of the Baffin Bay where it meets up with the nearest strait. I think there's something warming the water there. I'm not sure what. It's still open around these two edges of Svalbard, the west side and the south side here. Here's where it's come back in the Barents Sea. Here's where it's come back in the Kara Sea. And it's, see, here's Severnaya Zemlya. This little island is Komsomolets. So right around this island, that's where the big billowing of the dark methane that we see on CAMS. Here's the Laptev Sea. And see, this is ice. I mean, it's not totally solid. There are openings, but generally it's ice covered. So this is where we saw the methane coming off of the coast of Russia and coming out in the Laptev Sea, and here's the East Siberia Sea. We saw methane coming up here, and then this is the Bering Strait. We can see we've got ice coming back in the Bering Strait and down along the Alaska and Russia coastlines. And the Beaufort Sea is it's pretty much covered, iced up now. And then this Canadian archipelago, these tributaries are icing back up. Also, here in this northern part of this Hudson Bay area, see, we're getting ice there, and a little fringe of ice around the coastline, this west coastline on the Hudson Bay, and a little fringe of ice looks like around Greenland there. So we'll see what it's done this week. Here we were last Sunday in my show. Here's what it looked like. Now it may be, we may not see that much difference. It's thickening more than anything. So let's just click through and see what we've got. So here's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and here's today. So we saw mainly some regrowth here and and out here in Bering Strait, but here in the Barents Sea. That's all those. Now we'll go to the Navy models. This is from the U.S. Navy, sea ice thickness for the Arctic. Here's the color ledger on the right. The dark purple is about 1 meter thick. The light purple is about 1/2 meter thick. And then when you see the little lavender, the fringy ice, like here in the Kara Sea, that's between just forming and up to like 1/2 meter thick. The bright aqua is about 2 meters thick. The dark aqua is about 1.5 meters thick. And if you see the green, that's about 3 meters thick. If you see yellow, that's just over 3.5 meters thick. So those are the main colors you're going to see here. So with this extent, we can see here's the fringy ice. See. We've got a little aqua coming in on this east side of Greenland. More aqua forming. So this is where it's thickening here in quadrant 3 above Greenland. And we're starting to get more aqua here above Ellesmere Island, and this area is thickening up. This is what was left of the main part of the sea ice this year, the thickest ice. And you can see the purple and the lavender in the tributaries, and some aqua coming in. Here's the yellow, a little bit of yellow and green, just next to this little Canadian island, and just a tiny bit on this Greenland coastline. Here's a little hint of reddish orange. So that's going on up a little bit thicker. Here's the Beaufort Sea, and see, it's going from purple into the blues now. So that's about, let's see, the dark blue, that's about 1.25 meters thick. See, and see the blues. See, it's gradually changing from purple to blue, just across all of that. That's the thickening. We're starting to see a little bit of aqua around some of these island coastlines. See? So, next we have, this is the 30-day model. This was updated yesterday. So the data goes back 3 weeks, and the forecast goes out to next Saturday. So let's zoom in and see what it's going to do this week. Now watch, this is Franz Josef Land. See, it looks like the ice drift is like pulling the ice away from these islands. That's why we see the white come in. See? So this is in constant motion all year round. It's not static. It's always in constant motion. And we can see just some aqua starting to pop up here around the Russia coastline, and here in the Beaufort Sea. See, it's thickening. We're getting a little bit of aqua coming along Alaska here. And see, it's now thickening, but it is moving. It looks like it is sliding as it's thickening, it's sliding to the left. That's what the ice did last year and ended up, remember that what was left of the thickest sea ice, it ended up sliding into the Beaufort Sea. There's that. And here's the Beaufort Sea sea ice thickness. So Alaska's down here. With this close-up, we can see the aqua along the coastlines now. Here's Canada, and here's the yellow and a little bit of green, and the aqua, the bright aqua. So it is thickening. So let's look at this. Here's the 30-day animation. Yeah, you can see this sliding. If I just hold my pointer here at the end of this little island, even though it's thickening, it's moving too. So, and we're getting a little bit of red or reddish orange here in the forecast period. See, right around that little island. And it is thickening, and see, it goes into dark purple and going into blue here. Look how this coastline of Alaska, though, see, it pulls out. That's the ice drift. It pulls it away from the coastline. So there's that. Now we'll go to the Antarctic. This is sea ice thickness for today. And this is really melting fast. We can see this hole that's opened up on the north edge, north side. And this east side is melting down real fast. And see, it's melted up to the coastline here on the south end. Here's the Ross Sea. It's melted up to the Ross Ice Shelf here. And then this is on this west side. This is near the Pine Island Glacier and the Thwaites Glacier, and there's a big hole there. And here along this, this is the Western Peninsula here in this little armpit. It's opened up. Now it's raining almost right at the tippy point. It's raining there today. Raining very close to there. And I looked up, and this Western Peninsula does get rain about 50, what they say, 50 days. They might get a little bit of rain. So I didn't realize that they actually got rain, but I guess it's mainly out here on the end and in these island areas. But so let's run the model, the 30-day animation. Now, as we've talked about, the ice is totally different in the Antarctic than the Arctic. First of all, the ice is around the landmass rather than being in the center with the land around it. And the ice has to form out of salt water, here, and in the Arctic a lot of it is fresh water, so it's a whole different kind of ice. It freezes at different temperatures. Generally most of the ice melts during the summertime in the Antarctic, and they're heading into their summer. The sun is up, and the longest day of the year for them will be December 21st, when it's the shortest day of the year for the North Pole. I think it's the 21st, the 19th or 21st, something like that, the winter solstice. So look at how this ice just whittles down. Look up here on the northern side. See, it just, look at that. Look at, in the forecast period, just in this next week, how much it's going to melt. Now remember, the ozone hole is right up here too, so that's not helping matters any. It's really thinning down here in the Weddell Sea. This is where we have a lot of the thick ice. So I was going to stop it and we'll go through. Okay, here we are at the end of the forecast period, so we'll click back. Here we are today, so here's the hole. So watch up here on the north side and see how it thins out. Watch this. Day by day you can see a huge change, can't you? There it is. Okay, moving on. So 2 weeks in a row that National Snow and Ice Data Center didn't post any data, and for today, well, for yesterday, they post the day after, and so for November 27th, no data in the Arctic. Here's the latest on the sea ice extent from them. This is as of yesterday. The dotted line is 2012, where sea ice was at its lowest that year. And see, we're about to intersect with 2012. And we're running kind of parallel with this gray line, which is the median or average. So, you know, right now we're a tiny bit above 2012, but it looks like, you know, if it doesn't pick up with the extent refreeze, then we're going to intersect with 2012. No data for the Antarctic either. And here's on sea ice extent in the Antarctic. Here's our melt this year. The blue line is this year. This kind of greenish line was last year. And so we are way below last year. And the gray line is the median or average. So it's going to town. It's melting away. And that's all of those pictures. Now, going to Climate Reanalyzer. I have 2-meter temperature anomaly to start with. Here we are in the Arctic. See all these blues and the dark blues and the purples. This is colder than normal. And then on the southern point of Greenland, looks like a chili pepper with reds and up into the pink zone. And that's this pink. That's about 24°C higher than normal. See, and it's raining, coming right up to the coastline. I don't know if it's raining on land or if it just kind of immediately turns to snow because it's much colder. I don't know. I'm not an expert on all of that. And here we've got a bunch of brown over the western U.S. and western Canada. Here's the Antarctic. They've been a lot warmer than normal this week, but it's right now that's at 1.6°C higher than normal. They'd been above 2°C higher this week. Globally, we're at 0.5°C higher than normal. The northern hemisphere is 1°C up. The Arctic is at minus 1.6°C. That's lower than normal. The Antarctic is up 1.6°C. Southern hemisphere is up 0.1°C. And the tropics are up 0.5°C higher than normal. Here's precipitation and clouds. And see this rain coming right up in the Baffin Bay and right up to the coastline. It looks like it's raining on land. That's not good. And we've got rain here by Iceland. And then we've got rain, let's see, just almost at these little islands at the Western Peninsula. And when this rain moves over, it does hit those islands. Now here's the jet clumps. There is no jet stream anymore. It broke last summer and it's getting worse. See these big loops and big breaks? That's where the cold air is swooping around. And see the southern hemisphere is broken up too. It makes no sense. We saw sea ice and snow cover. Here's sea surface temperature anomaly. This is from Friday, the 26th. We've still got browns here in the Barents Sea. Not too much in the Kara Sea anymore. We've still got reds and browns around Svalbard and in the North Atlantic and around Greenland. And here's the Hudson Bay. See, it's cooling down. It takes a long time for this water to cool down after it was ice free for so long in the summertime. We've got a red spot off the southern coast of Africa. Here's our red blob in the South Pacific. Look at this red just east of Japan. See, that's red and pink. And these, the seas, so we got a lot of browns there. And it's, a lot of browns around Australia and New Zealand, and so this water is warming up as they move into their summertime. So we'll see, more solid brown, sometimes reds even, especially in this Tasman Sea. It tends to heat up. Worldwide, we're up 0.4 C higher than normal. The northern hemisphere is up 0.6 C. The North Atlantic is up 0.8 C. The North Pacific is up 0.5 C. The southern hemisphere is up 0.2 C. And the equatorial Pacific is down 0.1 C. Now we're ready to move on to NASA Worldview to see what we can discern on the sea ice. So here we are in the Arctic today, and the dark circle, the black circle, that's where it's dark now, and we can see most of Greenland is in the dark. So this bottom portion that's much warmer than normal, see, it's in the sunlight, and we can here's the storm, the rainstorm, see, and here where it's raining by Iceland too. So we'll turn on the sea ice concentration layer. So here's the sea ice today. I'll turn on the blue marble layer and make it easier to see. There we go. We've got, see these colors here on this Russia coastline in this Sea of O coast. So just a little bit coming back there and up here in those little inlets. Here around Alaska and Russia, here in the Bering Strait. Now we want to see solid white for concentration. Even the pink color, it means it's not fully concentrated, meaning that there's like space between the pieces of ice, or it's not refrozen really well. We can't see the thickness here, we just see like how well it's frozen and the extent. Here is where it's refreezing, here in the Kara Sea. The Gulf of Ob is still refreezing, and here's the fringe here in the Barents Sea and around Greenland. And here's the Baffin Bay and Hudson Bay. So let's go back. So my show last Sunday was on the 21st. So let's see what's happened this week. I'll just click through. Here was Sunday. Here's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So this correlates with the other models that we just looked at. Now I'll turn off that layer, and I'm going to turn on the nighttime layer, and we'll see I was looking a little earlier, and this nighttime layer, it was difficult to really look at today. This layer doesn't always work. Let's see where it goes weird with the kaleidoscope effect. It's hard to really get your bearings and see anything. Here's Greenland. Here's Svalbard. We can see. Here's the ice edge. And here's Svalbard. See, this is ice free on this left side, and at the bottom here's some ice on the east side. Here's Franz Josef Land. See the little, those are lights on land. Here's Novaya Zemlya. Here's the ice. Okay. Now right up here, this is Komsomolets, and here's the coast, and this, it's hard to tell how much is cloud and how much is open water, but whatever ice is in this area, it's quite thin, and this is where we're seeing the methane billowing. So I'm pretty sure. Let me get my bearings right. Komsomolets. This is Severnaya Zemlya. And turn that off. And then this is the Laptev Sea here. These are just reflections here. So you see cracks right at the coastline. This looks like ships in the ice there, or lights of some kind. Here's the coastline. So let's see. This is New Siberian Islands. That's on land, that light. Here's, okay, see, here's some open water there. See, you can see it between the pieces of ice. And the leads need to refreeze, and there's a reflection there. See, this layer is not yielding good viewing today. Here's a long lead. See, this is not refrozen. That's open water. It's a big, it goes all the way across practically. See. So it starts down here. See, down here. You see the sea ice there. And let's get our bearings. So here's the archipelago, here's Ellesmere Island. So let's look now. Okay, so that crack, see, is right along through some of that thicker sea ice. Let's see. Now if we go back a couple of days, it's a little bit better viewing. See, here we are on the 26th. Now here's the coastline. Here's the these Canadian islands. See the open water there. Here are the leads. They're freezing, but it's slow. Here's open water there. This is Barrow, Alaska here, and see, this is the coastline where the ice pulls away. Here's the pieces of ice you can see, and the leads, you can see those. And here we can see leads going across all the way there. Here's some more big long one. So there's our ice. There it is today. So we'll turn that layer off. That's about all we can see up here today. Now we'll hop down to the Antarctic. Okay, here we are today. Let's start down here on this west side. See all this open water, a lot of melting going on. See, right up to the coast there. Now this is the Thwaites Glacier here, and this is the Pine Island Glacier. And for some reason it looks like more ice here today. My thought is that this ice is breaking up and spreading out. I don't think it's a refreeze. I think it's just like it's got to start moving out. See all these pieces? That's the melting. This is the sea ice here. Here's the where it had calved off a couple of summers ago. This is a hole in the ice there. See all this open water. Then coming around, open water. This is open. It's under a cloud right now. Let's look. See, here's yesterday. Let's go back. Here's the Western Peninsula. Now right here, this is where that A76 iceberg broke off, right up here. See, that's all open. And this is the Weddell Sea where it's breaking up and melting. Now, here's the Western Peninsula. It's under clouds right now, but this whole area is where we saw the methane coming up. See, there's open water. This is open. This is right here is the Larsen C ice shelf. And then up here is the Larsen B. But that's melting fast. You can see that. Let's go back. Why is that not? Here we go. Look, here it is on the 25th. Let's see. So we'll go back. Here we are today. See the ice? Now right here, this is the Brunt ice shelf here. This is open water where it's under a cloud. This is open. And this whole area we saw methane coming up all along here. Now we're moving up to the north end. Here we are. Let's see. Here's the hole. See, this is the hole that we saw on the Navy website. I think, yeah. And then here's the east side. Here's the Amory ice shelf. Methane's coming up all along here. See, that's open. There's a cloud. Look how this is melting. Here's this east side. See, a lot of it has already melted up to the coastline. And a lot of the coast might have just a little ice shelf around it. And that kind of hangs around longer than the sea ice. Now down here, this is the Totten Glacier. Now this tongue has really broken off this year. Now we're looking through some clouds. I was going to show y'all. Let's go. Now here we are on the 25th. See this tongue? That's cracked. And there's a crack going across this way, left and right. We'll go back. There it is today. Then here's the Ross Sea. We've got a bunch of clouds, but see how this is melted? And this is the Ross ice shelf. So it melts out. Here's Ross Island. See all that open water over here. This is where we saw methane coming up to this area. Let's zoom in. So here it was, the 25th. So we've had clouds a lot of the week. Here's the best view on the 25th. Let's see. And that's Mount Erebus, the volcano there. So that's what we've got right now. Uh-oh. Too far. Oh wow, they've already got some for tomorrow. Up, little square piece. Alright. That's what we've got. Now we'll go over earthquakes. We'll just look at the website here. 239 in the last 24 hours on USGS, and they're not reporting anything about La Palma. It's criminal. Now, you can see this big dot. This was a 7.5 that took place. This was in Peru, out in the forested area. I don't know if there was any damage to infrastructure. I don't know. You know how populated. It's probably not very populated at all there. But it was 112 kilometers deep. The depth kept it from being from shaking that much on the surface. So I'm sure it shook. That's a huge earthquake. So I just haven't looked to see what kind of damage there was. But this is active all the way down here in South America. Now Puerto Rico has an uptick today. They've got they've got 16 here right now. They're low, twos, mainly twos. And then in the South Pacific area, from Indonesia over Papua New Guinea and over to Fiji, we've got how many? 6 here, and they're in the 4s range. We've got some very deep ones too. Japan area has 3. See. We've got 1 on land down here, 4.6. Kokubu Matsuki, Japan. We've got 2 on this east edge of India. We've got 1 here in Iran and right on the border with Iraq. Now, here in the U.S., we've still got movement on this Juan de Fuca plate. We've had earthquakes on this plate or near here almost every day for the last couple of weeks. This is a 3.0 right at the base. This came in last night at about 11 p.m. Let's go, let's see, let's look at let's look at all magnitudes for the last week. We'll get an overview. Alright, 1,078 this last week, and we had a 5.5 up here off this northeast coast of Greenland. 5.2. We had a 4.9. This was a 4.9 just north of Svalbard, very near the North Pole. That one came in yesterday. We had one on the Reykjanes Ridge of 4.7. We've had more movement here in the South Atlantic, South Sandwich Islands. Also, see, look at all this movement around this Antarctic plate line. So that plate's been moving, and then of course you see all this movement around the Ring of Fire. Here was a 6.2 at Palma, Myanmar. We had 5.0 bomb Iran. We had some 6s this week. Where was it? Solomon Islands. Here. Wait. Here we go. 6.0 Solomon Islands on the 25th. Look at all of this. Look at Alaska. Oh, I was going to show up here. We've got a cluster going on up here, just north of the Yukon Flats. 5 here now. 4.3. That one came in yesterday. And look at all this on the Juan de Fuca plate. Look at this. A lot. Look at this. I'm concerned. Let's see. Look at all of those. We had a 4.0 that was on the 24th, and then another 4.0 on the 26th, and just lots of movement there. And then, of course, always along the San Andreas fault line, but down here at the other end, it becomes the Imperial fault line at the Salton Sea. It continues down, and look at all this movement here. This is the Gulf of California, right on the red line of the Imperial fault line. We had 5 here, and there were 4s. 4.9 was the largest. La Libertad, Mexico, is the reporting station. So that's concerning. And then all this in South America, and then this big one, 7.5 today. That came in at 2:52 this morning, Pacific time. So I'm, every week that goes by and we're still here, I'm just amazed. And I do believe we are in the end times, and that's why I keep doing this reporting. And these times were prophesied of by Jesus and by others in the Bible, but mainly by Jesus. And so I like to finish up the shows with a Bible reading, just to bring us back to a spiritual perspective. And I'm reading out of the book of Mark, and the first 4 books in the Old Testament were about Jesus' life. And so Mark is the second book in the Old Testament. And so we're on Mark chapter 11, and the red words, the red text is Jesus' words. Mark chapter 11. And when they came nigh to Jerusalem, unto Bethphage and Bethany, at the Mount of Olives, he sendeth forth 2 of his disciples, and saith unto them, Go your way into the village over against you, and as soon as ye be entered into it, ye shall find a colt tied, whereon never man sat. Loose him, and bring him. And if any man say unto you, Why do ye this? Say ye that the Lord hath need of him, and straightway he will send him hither. And they went their way, and found the colt tied by the door, without, in a place where 2 ways met. And they loose him. And certain of them that stood there said unto them, Why do ye, loosing the colt? And they said unto them, even as Jesus had commanded, and they let them go. And they brought the colt to Jesus, and cast their garments on him. And he sat upon him. And many spread their garments in the way, and others cut down branches off the trees, and strawed them in the way. And they that went before, and they that followed, cried, saying, Hosanna! Blessed is he that cometh in the name of the Lord. Blessed be the kingdom of our father David, that cometh in the name of the Lord. Hosanna in the highest. And Jesus entered into Jerusalem, and into the temple. And when he had looked round about upon all things, and now the eventide was come, he went out unto Bethany with the 12. And on the morrow, when they were come from Bethany, he was hungry. And seeing a fig tree afar off, having leaves, he came, if haply he might find anything thereon. And when he came to it, he found nothing but leaves, for the time of figs was not yet. And Jesus answered and said unto it, No man shall eat fruit of thee hereafter forever. And his disciples heard it. And they come to Jerusalem, and Jesus went into the temple, and began to cast them out that sold and bought in the temple, and overthrew the tables of the money changers, and the seats of them that sold doves, and would not suffer that any man should carry any vessel through the temple. And he taught, saying unto them, Is it not written, My house shall be called of all nations the house of prayer? But ye have made it a den of thieves. And the scribes and chief priests heard it, and sought how they might destroy him, for they feared him, because all the people was astonished at his doctrine. And when even was come, he went out of the city. And in the morning, as they passed by, they saw the fig tree dried up from the roots. And Peter, calling to remembrance, saith unto him, Master, behold, the fig tree which thou cursest is withered away. And Jesus answering saith unto them, Have faith in God, for verily I say unto you, that whosoever shall say unto this mountain, Be thou removed, and be thou cast into the sea, and shall not doubt in his heart, but shall believe that those things which he saith shall come to pass, he shall have whatsoever he saith. Therefore I say unto you, what things soever ye desire, when ye pray, believe that ye receive them, and ye shall have them. And when ye stand praying, forgive, if ye have aught against any, that your Father also, which is in heaven, may forgive you your trespasses. But if ye do not forgive, neither will your Father, which is in heaven, forgive your trespasses. And they come again to Jerusalem, and as he was walking in the temple, there come to him the chief priests and the scribes and the elders, and say unto him, By what authority doest thou these things? And who gave thee this authority to do these things? And Jesus answered and said unto them, I will also ask of you one question, and answer me, and I will tell you by what authority I do these things. The baptism of John, was it from heaven or of men? Answer me. And they reasoned with themselves, saying, If we shall say from heaven, he will say, Why then did ye not believe him? But if we shall say of men, they feared the people, for all men counted John that he was a prophet indeed. And they answered and said unto Jesus, We cannot tell. And Jesus answering saith unto them, Neither do I tell you by what authority I do those things. Matthew chapter 11. So as we head into collapse of the planet on all different levels. We really need to think about the spiritual part and think about what's going to happen when you leave the planet. Where are you going to go? Jesus said, I am the way, the truth, and the life, and the only way to my Father's kingdom is through me, meaning the only way to heaven is through Him. And we're in a spiritual battle. It's a spiritual battle between Satan and God, and Jesus is the Son of God, and Jesus is the one who can overcome Satan. We cannot without Him. We cannot overcome Satan without Jesus. So, I'm praying for everyone. If you haven't given your life to Jesus Christ, I highly recommend it now before it's too late. So, I love you and I'm praying for you. Until next time, God bless you. Go in peace, and I will talk to you soon. Good night.